Alright, let's start with the first problem. The first problem is about um, it requires the number of millimeters required from 15% weight per volume concentrate of benzalkonium chloride to prepare 300 milliliters of a stock solution. That stock solution, when we dilute 15 milli of it to 1 liter, which is also 1000 milliliters, will yield a solution which concentration is 1 to 5000. Alright, but before we illustrate this um, problem, we should know some basics of the dilution problems. Okay, suppose that we dissolve 5 grams of any substance in 100 milliliters of water. So the concentration of this solution is 5 grams per 100 milliliters, or it is 0.05 grams per milliliter. And to convert this into milligrams per milliliter, we multiply this number by 1000, so we get 50 milligrams per milliliter. Okay, now we suppose that we dilute this solution by taking 2 millis of this solution and put these 2 millis in 100 milli flask, and we complete volume 2 100 millis. So we took 2 millis, and 1 milli contains 50 milligrams. So 2 millis would contain 100 milligrams. So we now have of this solution here 100 milligrams of substance dissolved in or contained in 100 millis. So it is 100 milligrams over 100 millis. So concentration is 1 milligram per milli. Okay, now if we dilute this solution here again by taking 3 millis and diluted it to 100 milli, so 3 millis would contain 3 milligrams. So the resultant solution would contain 3 milligrams in each 100 milli, or 0.03 milligrams per milli. Okay, so we started with 50 milligrams per milli, and then we diluted it to 1 milligram per milli, and then we diluted it again into 0.03 milligram per milli. Okay, now if we would to make easier calculation from this here solution into here, we would make it that way by we started with 5 grams per milliliter here, so we multiply it by this factor, this dilution factor, which is 2 over 100, and then we multiply it again by 3 over 100, so we get that the final solution would, or the concentration of the final solution would be 0.00003 grams per milli, or we can convert it into milligrams per milli by multiplying by 1000. So we got that the final concentration is 0.03 milligrams per milliliter. Now, a very important thing we must know that if we know that the solution here, which is the final solution, the concentration of it is 0.03 milligrams per milliliter, and we know that this solution resulted from the dilution of a stock solution or another solution. By diluting this stock solution, 3 millis of it to 100 millis. How can we get the concentration of the stock solution here? This is very simple. We go the opposite direction by we multiply this concentration here times 100 and then we divide by 3. So we multiply 0.03 times 100 over 3. So we get that the concentration of the stock solution is 1 milligrams per milliliter. And we can do the same to this to convert it to the original or the stock solution. So we multiply 1 milligrams per milliliter times 100 over 2 and we get that the concentration of the original solution or the first solution is 50 milligrams per milliliter. Okay, so after knowing these basics we can start solving our problem. Let's start. So by knowing the previous information we can now solve this problem. Okay, here we have a solution which we need to prepare 300 milliliters of it. Okay, and we don't know its concentration, but we know that if we took 15 milliliters of it and diluted it to 1 liter, or 1 liter is the same as 1000 milliliters, we get a solution which its concentration is 1 to 5000 solution. What does that mean? 1 to 5000 solution. It means that we have one part in 5000 parts, or it also means that we have 1 gram in 5000 grams of solution. Okay, and since this solution it's not mentioned that it's what is the solvent, so it's water. Since it's not mentioned what is the solvent, so the solvent is water. So we have 1 gram of substance in 5000 grams of water. 5000 grams of water is the same as 5000 milli of water, because the density of water is 1 grams per milli. Okay, so the concentration of the resultant solution is 1 gram per 5000 millis. Okay, now this solution here, which is a stock solution, to make this diluted solution is made by dilution from a stock solution, okay, from a concentrate of benzalkonium chloride solution. This concentrate or this stock solution concentration is 50% weight per volume. 15% weight per volume means 15 grams per 100 milliliters. Okay, so the stock solution concentration is 15 gram per 100 milliliters. Okay, and this stock solution or concentrate would be diluted to make 300 ml of this solution. Okay, so what we need to know is how many milliliters would be taken from this concentrate, okay, to prepare 300 ml of this solution. Okay, so looking at this solution, its concentration is expressed in grams per ml per 100 milliliters, and this solution here, its concentration is expressed in grams per 5,000 milliliters. So we should first convert the concentration of this solution from grams per 5,000 millis to grams per 100 millis as this solution. So we have 1 gram in 5,000 milliliters. So how many grams we have in 100 milliliters? So we multiply 100 times 1 over 5,000. So we got that the concentration of this solution is 0.02 grams per 100 milliliters. Okay, so we have now the concentration of this solution in grams per 100 millis, and we have the concentration of this solution in grams per 100 millis, and then we should know the concentration of this solution first here. So it's very easy, as we studied in the previous lecture, that to know the concentration of this solution, by knowing the concentration of the final resultant solution and by knowing how we diluted this solution to get this solution here, we go the opposite direction. We multiply 0.02 times 1000 over 15, and by doing that we get that the concentration of this solution is 1.3333 grams per 100 milliliters. Okay, so now we have three known concentrations. The concentration of the first concentrate of the first stock solution of benzalkonium chloride, which is 15 grams per 100 millis, and then we diluted to 300 millis, and we got a solution that its concentration is 1.3 grams per 100 millis, and then we diluted it again and got a solution of a concentration of 0.02 grams per 100 millis. Okay, now our unknown is to know how do we, or how many millis we should take from this solution to get this solution. We know the concentration of this solution and we know the concentration of this solution. Now we should know how many millis to take from this solution in 300 milliliters to make this solution here. Okay, so the concentration of this solution here is 1.3 grams in every 100 millis. We need to make 300 millis, so we need 3 times this weight of benzalkonium chloride in 300 millis, right? So we multiply 1.3 times 3, and we get that this weight is 4 grams in 300 millis. Okay, so we need to have here 4 grams, and to calculate what millis we need from this solution, it's very easy. We need And we know that this solution, in each 100 milliliters we have 15 grams. So we have 15 grams in each 100 milliliters. So from how many milliliters we can get 4 grams? It's very simple cross multiplication. We multiply 100 times 4 over 15. So we get that we need 26.66 milliliters of this solution here to make this solution, and this is the answer. We can solve this problem um, by another way. How can we solve it? Reaching the point that we know the concentration of this solution and concentration of this solution, we know that the volume needed is 300 milliliters of this solution. And it's to make it easy, we can use the equation of C1V1 equals C2V2. C is concentration and V is volume. So we multiply the concentration times the volume, and it's equal the concentration and the second volume. Okay, so first the concentration is 1.3 grams per 100 milliliters. Okay, and the volume of it is, yes, 300 milliliters. This equals to the concentration of the stock solution, which is 15 grams per 100 milliliters, times the unknown volume. Okay, and to get the unknown volume, we should multiply this and divide it by this. We can cancel this 100 milliliters with this 100 milliliters, and we end up with 1.3 times 300 over 15, and that would give us the same answer, which is 26.66 milliliters, which is our answer.